clumped together or clumped together. So we'll have a non-uniform material. And our goal is to modify this process to have a better mixing efficiency. So we developed a sonoshear mixer that is combination or integration of ultrasound mechanism and also high shear stress during mixing of the particles and molten metal, so we can get a uniform dispersion of the particles, and then we will have a uniform, highly reliable material properties compared to the when that they don't have this mixer, so that they can provide large blocks, large parts like cylinder in automotive, compared to the small parts that are currently prepared in industry. And this metal matrix composite has a wide or huge application. They can be used in aerospace, biomedical engineering, automotive, electronics, defense, and also sports. And for example, you can see here a metal matrix composite for antenna in satellite, the other parts of automotive, and brakes, for example, for the cars. So what have we done up to now was developing and prototyping this mixer, and we have published it. We get a best paper award in a conference, and then physical and numerical modeling and also patenting are ongoing. Here you can find the QR code to our recent paper. And we estimated to get to the first MVP in 12 months. And the goal is to apply for STBIR or STTR seed funding phase 1 to develop it. And it can be through different agencies like NSF, NASA, or DoD. And then in future, after the first product, after 6 to 8 months after the first product, we can start selling through the selling the mixer, customize it, selling the material to the companies, and also custom R&D projects. Our team management consists of Dr. Mehdi Razavi, Scientific Advisory Board. He is Associate Professor at University of Central Florida. I am CEO of the company, the future company, and I have PhD in material science. And Andres Laraza is the head of engineering. He's going to solve the technical problems of the company. The next step in 1 or 2 years, as I mentioned, it's going to develop first product, publish the result, apply for seed funding phase 1, and then for 3 to 5 years, we are going to apply for seed funding phase 2 for more R&D and scaling up and establish partners and find more applications. Thank you very much for your attention. We also need to acknowledge seed funding from NSF that helped us to start this project.
Thank you very much. Good work, Pedram. Thanks for sharing that interesting
Thank you.
presentation. And now we have time for questions. We are missing 2 of our original advisors, panelists, but I do want to point out 2 more people who are present. You're welcome also to ask questions. That's Louise Z. And let's see, we've got Mo Ken Swisher. So both of you are also welcome.
And Tara, I'm here as well. I don't know if I'm on your list.
Erock Christopher?
Yeah.
You're not on my list. Interesting.
Should be.
Anybody, you know what? All 4 or 5 of you have preliminary options to ask questions, but I'll start with Richard or Erica. Erica's got her hand up, so
just
there we go.
All right, real quick. Erock, I think you're on the 2A track.
Oh, am I on the wrong track?
Yeah, you're in 2B right now.
Okay. All right. Well, then 2B or not 2B, I'll go to A.
Sorry about that.
Oh no, All right, I go where? Is there a place to hit the leave button or leave the room?
Leave room.
Thank you. Sorry to interrupt.
All right. So thank you to the team. Pedro, really nice presentation. I think
Thank
a lot
you.
of that was very clear and concise messaging, which I really appreciated. My question for you is in terms of go-to-market strategies for the products themselves. I love the SBIR strategy for getting capital in the door, but how do you envision entering the market with these products? Are these direct drop-in replacement for existing products, or are they going to have to displace something else?
So currently, there are two methods that company are preparing these metal matrix composites. One of them is powder metallurgy. It's mixing powder of metal and nanoparticles and then making a sample out of it. But the problem or the limitation is that they can prepare only small parts, very small parts like gears, and that's not efficient. The other method is casting, metal casting companies, but currently they are, it's not as wide as powder metallurgy because in that companies, they will have non-uniform properties. So we are going to do R&D, more established technology, and then provide it to the companies to sell them.
So just to clarify there, you're going to provide the R&D outputs as opposed to products, the actual
So
solid
it
shear
can
mixtures
be,
yourself?
it can be both of them. It can be selling the device and installation for the companies so they can prepare the material themselves, or they can ask us to do R&D projects for them.
Got it. Thank you.
Sure.
Yeah, Richard, you're welcome to join in.
Wonderful. Thank you. It's super interesting. So a bit of my background is almost 30 years of military aviation, of which half of that is test piloting. So I'm fascinated by your use case here.
Thank you.
A first question is along the lines of the funding strategy. You list a couple of options out there. Normally, when you do these SBIRs or SCTRs, you have a transition partner in mind, somebody who's a logical corollary, and then a long-term transition partner. Can you give me a little bit of insight on what that strategy might look like?
Yes. So because the technology is developed in University of Central Florida, the agency would be University of Central Florida, and probably it would be through STTR. So we can use the facilities that we have here. We have started work here, and we prefer to be partner with university until we get separated and we can have a company on ourselves.
Okay, so I'm guessing then the IP strategy is going to be inside your tech transition office,
Yes.
internal to the university. Okay,
Yes,
wonderful.
exactly.
Recommendation on that, if you have not already connected to a gentleman named Paul Soul in the Florida high-tech corridor, I would recommend another test pilot colleague, happy to pass that along later, last name Sohl, but a military test pilot who's there in the Florida ecosystem, in a bit of a legend in our world. Next one's a recommendation. So as you present this information in the future to a somewhat broader audience who may not have as deep of a technical knowledge, I would recommend that you start out perhaps with a storyline or a vignette that says, here is a large clunky thing that is very heavy and very expensive and vaguely unreliable. Because it's unreliable, we had to make it bigger. With our technology, using this device, and I hear two tracks. One, sonar shear, meaning using that level of energy in order to provide purity of mix is how I understand that. The second piece is a service of some sort, which provides that service to others. Those are two very independent things, but I would certainly have the ability to tell a story about each of them, perhaps on, to Erica's point, the thing you would displace, the thing that you would be going after, or how somebody would use this in order to enhance their products or displace a competitor. And that in a storyline format that does not have an X and a Y axis will generally land fairly well for those that are kind of warming up to give you a chance to then dive down inside these very technical details.
Perfect. Thank you.
Yeah, and Tara, I'm happy to hand it over. I have other ones, but I want to make sure we have other folks can ask.
Well, let's
Thank
see.
you
We
very much.
Thank you. We have 3.5 minutes left. Shay did join us, but she probably didn't hear the presentation, so
Okay.
she's here for the
I'm
future
happy.
ones. So
Okay.
we'll happy to
The,
have her join us next time. And then if I'd just like to ask Mo and Luis if you've got any thoughts or comments or questions, feel free.
Hi, Pedram. Good job.
Hi,
Um,
thank you so much.
You're welcome. I agree totally with Richard. In fact, he took a couple of things that I was going to share. And so I'll just put an exclamation point on those. But the one that I really want to emphasize is the explanation and being very explicit that you're going to offer both a product that they can actually buy the SonoShear and do this work themselves, or they can buy a service from your company that will in turn work on that and then provide the results. So those are two different revenue streams. Very important for people to know that you've got two different ways of earning revenue and perhaps even more. And then another one, which is, investors are in love with, is any data that you discover or that you can grab as a result of the services that you do. That data is an asset. And so being able to do something with that data to sell it to whomever might be interested is a third revenue stream, something you might want to think about. And that's it for me.
Okay, thank you. So what do you mean by data? I mean, something published or something with the previous customer?
Something that is derived from the customer, and I don't know if there even is any, but if any data comes from using the SonoSort or to be able to be meaningful or useful to another entity that you would have rights to somehow, or even pay the company that you did the service for to utilize that data somewhere else is another revenue stream. I'm not even sure if you'll produce that, but if you do, there's a valuable asset there.
Okay, perfect. Thank you.
You're welcome.
And I don't know, Luis, do you have anything you would like to add? Thoughts, questions?
No, apologies there. I was not really reviewing this one, just listening in, but thanks for asking.
All right. Okay. Then we've got a minute left for anybody in the audience. Or Richard.
Yeah,
Please.
so another item. You list MVP, which in this entrepreneurship innovation space can be many things to many people. I would be explicit if you're talking about a minimum viable product in the lean launch sense, in which case that is not a concrete prototype in hand. So I'd be perhaps differentiate whether or not a model, for instance, is actually a highly formed MVP, minimum viable product in the lean launch sense. But if you're talking specifically the prototype of the mixing unit, I would just be explicit about what those things are, because it makes it sound like you're a year away from even touching the unit itself, when in reality you have models, you have many things that are far along the path from a research, and I say it as a basic and applied research person as well, to depict that storyline. Graphically doing that will help people understand what that end product looks like, and then you'll have pieces of the model itself, and there may be reliability and maintenance, maintainability type data to Mo's point that you may be able to start to glean as you refine that model over time. And I'll end there.
Yeah,
I'm just thank you.
I'm just going to double click on that, because I think that what the presentation does really well right now is to show the problem that you're trying to solve, but not yet how mature your solution is.
Okay.
Thank you so much.
All right. Thank you so much, Pedram. We're going to move on to the next group.
You're welcome.
That is Blackstar Orbital.
Here we go. All right, I'm going to go ahead and share my screen now. All right, do you guys see it? All right, we're ready to begin when you are. Just let me know when the clock's running.
Go.
All right, everybody. Good morning and good afternoon, depending on which coast you are. This is Christopher Jeanette, co-founder and CEO of Blackstar Orbital. This has been a great accelerator program to be a part of. We made lots of new colleagues, let's call them, and we're looking forward to present some of what we've learned. We're going to do things a little bit differently. Let's start by introducing the team. As you guys know, I'm Chris, formerly the lead hypergolic propellants engineer for NASA's K-Please 2. Prior to that, I was on SpaceX Starship. Kit Carson, my co-founder, was the lead product manager on Amazon Kuiper. I've worked with him for several years on this. In fact, Blackstar's been in stealth since about 2017. Joining us today is none other than Elizabeth Christensen. She's the head of the Southern Iowa Business Development Center. She's also a key member of the Arizona Spaceport Alliance. Many of the relationships that we built in Arizona to get our $7.3 million capital investment with the state was directly because of Elizabeth. So I definitely needed to give her a shout out. And finally, Sean Hollis, our Chief Commerce Officer, was one of the lead engineers on NASA TOSC. Also was involved with the TPS system on Orion. He's held many C-suite roles in many different organizations. We also have some great advisors. I'm just going to do some highlights. We have NASA astronauts retired. We have lead PhDs in the field. We have certified ethical hackers. We have orbital warfare officers from Cheyenne Mountain. We have economists and Wall Street lawyers, everybody helping to lead this program. So without further ado, at Blackstar Orbital, we are redefining what a satellite can do by redefining what a satellite is. How exactly are we doing that? We are building spacecraft which launch like a traditional payload and return home just like a space plane. I have a little model right here because space exploration has changed and because the future is, well, future is here. So we built the BX-100 space drone. What you see is a vehicle that is about 1.5 meters long for the MVP, and it's growing, scaling and growing in the number of customers we're getting. We're about 128 million and counting. So Blackstar overcomes many limiting factors associated with satellites. Space debris, every launch is debris generating, short lifespan. Those satellites last only 5 years. They run out because of fuel. They run out because of micrometeorite damage. So why not bring them home? If 20% of satellites are dead on arrival, let's bring them home if there's an anomaly by landing at one of the 14,000 runways worldwide longer than 5,000 feet. Blackstar comes in many different flavors. I think the one that Space Edge will be most excited to hear is the Discovery, the Cargo, and CubeSat, being able to host many different life science and material science modalities for our colleagues here in the accelerator. The BX-100 space drone, as I pointed out, is about 1.5 meters long. We're using a green gas that's it's a hypergolic, but it's a non-toxic one. And coming from that world of hypergols, you do not want to use hydrazine. It's bad news, guys. Let's evolve a little bit. So let's talk about the modular payload bay. As you see there, this is really what the vehicle is built around. It's a 20U multimodal system that's capable of having many different systems swapped in and out of it. Whether you're doing life science research, whether you're doing a communication or navigation system, whether you're doing optical OISL, optical interlinks, whether you get the idea, right? We can do a lot. And biomed is a growing need. So talking about biomed, well, as you know, these single-use satellites lack the flexibility, limited access to microgravity environments, high costs associated with space, as you guys are aware through this program, and important research that can be a game changer for quality of life back on Earth is prohibited due to lack of access. So let's democratize space access through flying and chartering miniaturized Blackstars that can host your life science payloads, because that's why we exist. We are here to justify your existence as biomedical space startups. So our Space Edge solution is the modular payload bay, which you saw earlier. Everything from biomedical research equipment to variable gravity experimentation. We are reuse capable, meaning that if you have what we like to call space age, we are trademarking that, by the way, this can come in other forms. Think direct consumer payloads. Everything from spirits to home research and science. We can do that with the Blackstar. For biomedical research, let's talk cellular tissue studies, pharmaceuticals, and biomanufacturing and biofabrication. So here's another opportunity for you guys. Reach out to Blackstar because we can customize our payloads for you so we can launch and host your payloads so you can get your research done. This is research that belongs to you. So let's enable those dreams and those goals. One thing I'd like to show you pictured is astrobiology as well. We don't really talk about that in this cohort. Maybe we will in 20 or 30 years once we're exploring the solar system and beyond. But one thing we like to show is a weather balloon that could suspend a black star in Venus's atmosphere or Jupiter's atmosphere so we can get that high fidelity scientific data. We hit many different market verticals, guys. Right now we're focusing on the $100 billion R&D science community. We're excited about Orbital Reef. We're excited about the commercial space companies, the commercial space station companies, I should say, that will be driving the next generation of research as trailblazed by the ISS. That's a little bit about our business plan. We're partnering with Paragon Space Development, U.S. Space Force, and our own Problem Solved Aerospace, shout out Jeffrey, on this program for the modular payload bay. We see this as a 36-month program with a 24-month go-to-market strategy. A little bit of traction here. We've submitted our patents. We've completed an SBIR program last year. Can't say which one, but we might have won an SBIR phase 2 in the past week. However, I can't tell you whether or not we won it. You'll have to read the blog at spacedrone.io to learn more. We also have about $125 million of customer LOIs, purchase orders, and like conversions. We have fantastic partnerships. I'm an ASU alumni, so it's a real honor to be coming back to ASU to be presenting this to you guys today as somebody who just 7 years ago was in the programs that many of you were attending, wondering and dreaming up what would become the Blackstar. And these things are worth it if you drive hard enough to make it a reality. So we're there. We're making it happen with our mineral viable product approach. We're looking to raise about 7.5 million seed to get our BX50 flight hardware, BX100, 24 months we got it. And last slide, join us. We are launching the BX50 in December 2025, Transporter 12 out of Vandenberg. Please be there. And if you'd like to get hosted, we'll make sure it happens. Thank you.
All right. Thanks, Chris. All right. To our panelists, if you've got any questions, go ahead and raise your hand, and I'll call you out there. So, Erica, Richard. Oh, Richard's got his hand up. Go ahead.
I'll go ahead and start. So fascinating, interesting, and a lot of information. I appreciate the presentation flow and all that. I hear two competing stories in there. Obviously, depth of technical stuff. There's a lot of wonderful things in there. I hear two competing stories. One is we've been around since 2017 and we do this. The other is we need a 24 or a 36-month strategy and a 24-month go-to-market, and we need $7.5 million. Can you kind of tie those two bookends?
Absolutely.
On
Yes, sir. So in 2017, my co-founders got together, and this actually ties into the background history. We were originally doing an ocean launch rocket. We were looking at hypersonics and defensive applications. It wasn't until we met with Terry Virts and he asked us the question, what else are you looking into hypersonics with? To which we replied, what about a pre-positioned hypersonic asset on orbit? We then raised about $2 million December of 2019. COVID hit. And from there, we were able to refine the ocean launch rocket program into the Blackstar program. Now, in the interim, I ended up going back to NASA, ended up going back to SpaceX to make things work. COVID economy is what it was, but not only did we survive, but the strongest alloys are often forged in the hottest fires and pressures. So you did pick up on those competing narratives. There was more history behind it, but hopefully that elucidates a little bit about the narrative.
Yes. So recommendation, condense that down, pick the winning horse that you're on, and I would offload maybe 30 to 40% of the periphery of this. If the ask is for $7.5 million, then I would focus on $7.5 million for this vehicle that connects to this piece that is with this partner in transition and this customer and in this time window. And that is just super tangible. That is very easy to get behind. And then the inflection point on where you go from there.
Absolutely.
And I'll share for some others, but if we have time to come back, 20U payload, some cost benefit trade-off analysis between can I just make one more of these small sats for a cheaper cost than having you go launch, get it, ferry it back. Those kinds of things I think would be important to put the market dynamics of that space would be helpful. But very interesting, and happy to talk more later.
Wonderful. Thank you, Richard. And we have some of those answers for you too.
Okay, and I see Erica and then Shay.
I think we had Colleen first.
Yes, we do. I was trying to go through the advisors first.
Totally, absolutely.
We'll get there. We'll get to Colleen.
So, yeah, really nice job, team. I think, as was mentioned already, a lot of information here. Getting the story pared down to just the essentials will help us to follow and also give you more time on a given slide for folks to digest it. So just sort of general feedback there. I think that there's been a lot of investment in this market that you're not yet highlighting, sort of talking about how much is going into to other companies' programs that are addressable by your vehicle would be really helpful to show the path forward for an investor to have ROI. To that question, hypersonics is one that you've called out a few times here. A lot of the hypersonics programs really looking for not just screaming back through the atmosphere, but time in a given environmental condition. Boost glide being a more traditional path towards that. Can you talk a little bit about how your technology fits that market?
Absolutely. And as a matter of fact, I have some appendix slides if you can just indulge me for 2 seconds. We have here, let's talk about this real quick. So the Blackstar, as I pointed out, comes in many different modalities. The way it launches like a traditional satellite, operates like a traditional satellite, lands like a space plane. As you accurately pointed out, there are other operators in this field, whether it's Varda Space or Inversion or say Space Rider out in Europe. What we're looking to do is we're looking to drive the values home to the customer by having the refurb costs be about 1/3 that of a brand new vehicle, allowing the customer to essentially buy 3 Blackstars for the cost of a single brand new satellite. What was the second half of your question, Erica?
Time in a given environment, screaming through the atmosphere doesn't help everybody.
Absolutely. Well, the great thing about this is we have a fantastic research payload, a research platform, if you will. And in fact, if you see right here on our tech tree, in our appendix, we have the hypersonic test platform in Orbital Sentry right there. That is where we're looking to reach out to customers who might be interested in doing things like material science. We definitely see that there's an unexplored regime when it comes to the near space, suborbital, and hypersonic regimes. We feel that with a space plane that can be both boost glided or just returned from orbit, we can operate in that regime, and we can operate with greater efficiencies over time. It's not easy. As SpaceX like to say, their test program is hardware rich. So we do expect there to be some interesting lessons to be learned along the way.
Thank you.
You're very welcome.
Okay, Shay. We have
Awesome.
44 minutes. Yep.
Perfect. No, I think you did a great job in 5 minutes to be able to condense this much information, much less a space tech, high tech company in 5 minutes. It's extremely difficult. So I think you did a great job, and I appreciate the highlights on the team because that's certainly a big strong point that you guys have. So I thought you did a great job maintaining enthusiasm and really condensing a difficult to understand product and market in just that short time. I think your most powerful slides too, and maybe just this is as a piece of feedback, is where your product's at. Those were the most engaging, and I found myself wondering those questions. So I think that double clicking down on where the product payload, et cetera, is focusing it on is much more useful because as an investor, right, we want to understand where your product differentiates from possible existing in the market. So that's a good key piece. One question I had, and piggybacking off of one that was asked earlier, in that 2017 to pre-seed raise time period, I know you guys were juggling a couple different things and going back and forth from their full-time jobs to this. Was there what happened to the dilution and the equity that you guys had raised? Is that still existing in the company, or did you guys do any reorging, or what did that look like in that time frame?
I'm glad you brought that up. We're really good at writing contracts. So when COVID hit, we were able to retain our 100% of our IP, which we are now rolling into Blackstar. Luckily, because it wasn't of any fault of our own, or even really our investors, it was just market forces that affected everybody. We were able to, have a very clean solution that allowed us to relaunch. Maybe it was only about 12 months later. I mean, we didn't really stop the entire time, but we did do a reorg. But all the original crew stayed along with us. They stayed with the team. It was amazing to see the amount of loyalty there. And now we have what we feel is a better product. Somebody once said to us, and I'll never forget it, and this is good for everybody, just a life lesson in general. Sometimes your bad luck will protect you from worst luck. And that's exactly how we approached the COVID economy. We see that as a blessing in disguise. That tech tree would not have existed in quite this way had COVID not happened. Obviously, silver lining and hindsight being what it is.
Yeah, it's a fantastic story. So condensing it in 5 minutes is difficult, but appreciate the clarity afterwards.
Cheers. Thank you.
All right, Colleen.
Thank you. Hi, Chris. Good to see you.
Hello. Good to see you.
Amazing.
At last.
I love this. This deck looks a lot different than what I've seen before. And number one, crossing fingers on phase 2 for you. I'll be looking out the press for that. And the question I had, you mentioned the biological samples for the life science payloads. Are you working specifically with Paragon on that, or is that kind of open to any of your partners? What's your thought there? Because that's the first time we've talked about that.
That's a great question. We're looking to develop with Paragon solutions for their micro ECLSS architecture to allow us to maintain a proper environment, temperature, humidity, etc. Inside the modular payload bay itself, they have some technology that they developed back in the 90s, actually, which has been basically in cold storage since then. So, in speaking with the team, there's some exciting opportunities there. And what this allows everybody who has life science payloads to do is essentially have a plug and play solution for the Blackstar where they can host their research, own their research, and wear their Sherpa to take it to where they need and to return it home to them.
Okay.
Awesome.
Hopefully that
I definitely
got
want
it.
to see you in Vandenberg, so we'll be talking.
December.
All right, December. Okay. Damon, I see your hand, but we only have 10 seconds left. So I would ask that you please maybe do a private chat with Chris or submit a feedback form. It's just unfortunately, we want to stay on time here.
Okay.
Apologize.
I'm on LinkedIn.
Oh, great. On LinkedIn. Okay. Okay. Thanks so much, Chris. That was great. Lots of good conversation. Do we have Melagen Labs in the room?
Yes.
Okay, you're up next.
Awesome. Let's do it. Give me a minute and I'll start sharing. Cool. Thank you. And I'm Mohammed, CEO and co-founder at Melagen Labs. And today I'll be going over the biggest challenge stopping us from becoming a spacefaring civilization and what we're doing at Melagen Labs to solve it. So right now, today, there are over 12,000 plus satellites orbiting the Earth, Moon, and planets. And 24,000 plus satellites are going to be launched in the next 4 years. In addition to satellites being launched constantly at an increasingly rapid rate, there are over 30 space tourism companies worldwide that are going to launch hundreds of off-world travelers in just the next year. This is such an exciting time. However, as space becomes more populated by electronics and humans, we must protect ourselves from the greatest danger that comes with stepping outside of Earth's protective bubble: space radiation. Current industry standard shielding fails to actually protect our satellites, electronics, and humans in extraterrestrial environments. 38% of satellites and electronic systems still fail. This means satellite companies are burning over 2 billion every year due to radiation-induced failures, with no clear solution in sight. Industry standard shielding adds millions of dollars to build and launch costs, yet the shielding effectiveness decays by 5% annually, leading to failure before mission completion. And within just a year of deep space exposure, astronauts face a 10,000 times increase in radiation, doubling their cancer risk. So if we want to achieve multiplanetary human civilizations, we need to solve one of the biggest problems stopping us from becoming a spacefaring civilization. So at Melagen Labs, we are a team of experts and help every satellite and space company solve the problem. And in pursuit of that, we have developed a proprietary composite of a hydrogen-infused proprietary polymer biomaterial to effectively shield our electronics and humans against radiation. Our proprietary composite is over 3 times lighter, 2 times more effective at shielding, extends the lifespan of systems by 5 times, and helps our customers save over 60% in shielding related costs. This technology has applications across both space and Earth markets. In the medical and nuclear industries, over 4 billion is currently spent on radiation shielding annually. It is projected to grow to 6 billion within the next 8 years. Additionally, the satellite market alone represents a $4 billion opportunity for us over the next 5 years. And that is why we are starting with the satellite market, providing conformal coating and enclosure shielding, leveraging our strong network and existing progress. But over time, we will transition into the aerospace, medical, and nuclear markets. And we've got a dream team ready to make this happen. I was working with NASA Space, leading a team of PhDs and professionals, and had the realization that NASA is way too slow to solve this. Our CTO, Dr. James Seacrest, is a Navy veteran with 25 plus years of experience in biotech and space business. Our business development lead, Hari Mahesh, scaled technology at Johnson & Johnson. And our advisory board is stacked with experts who have raised 100 million and successfully exited a company and run radiation shielding programs. So it's no wonder why we're gaining incredible momentum. We have over 1 million LOIs and MOUs showing strong market validation. And within 8 months, we've raised 200,000 in funding. And I'm also thrilled to share that we have two major space launches lined up this year, one in cislunar orbit, another one in low Earth orbit. And we're also backed by Techstars. If there's one thing that you walk away from this, is that space radiation is the biggest problem stopping us from becoming a spacefaring civilization. And at Melagen Labs, we're solving it. If you want to be part of the journey, or if you have any introduction to satellite operators or satellite manufacturers, I'd love to connect and we should talk. Thank you so much.
Thank you so much. That was very informative and to the point. Advisors, hands up. I see Erica has some questions or advice.
Hey, thanks, Mohammed. Could you go back to your slide that shows me the details on your product?
Yes. There we go.
So can you tell me more about your product? I'm still a little confused at what it is that you're actually making and offering.
Yeah, definitely. So there are two ways we could protect electronics in space. One is conformal coating. So the Melagen shielding that you're looking at, this one, it's a coating material, usually known as conformal coating, that can be just sprayed on electronics. And this is an actual prototype that we did for potential lead. So it's already in pilot programs and being implemented. This that you're looking at, enclosures, they are 3D printable. And this is essentially revolutionary because we're able to print hydrogen infused biomaterial. And that could be printed as simple structures, covers for the PCBs, etc. So it makes it more flexible and accessible for any sort of satellite and extra shielding. Does that make sense?
Yep. So you have a materials patent or some other IP protection for a unique material, and
Yeah,
how much?
Yeah, go ahead.
And how much better is it than industry standards?
Yeah, great question. So we're only 8 months old, and we started off with provisional patents. So there's still a lot more that we have to do in terms of IP. But we see it as, okay, this is top priority, and we're working on that. So we have some provisional patents in. In terms of effectiveness compared to the industry standard, depends on the orbit, though. The results that we've been getting from actual space radiation testing here terrestrially that we've done, it shows that it is 2 to 3 times more effective. And most effective for us is geo orbit, and that's where a lot of radiation problems come in.
Geo orbit because you're preferentially filtering out GCRs?
Yeah, GCRs and also protons. And on top of that, the degradation that leads to shielding effectiveness decreasing. So that's secondary radiation. So we reduce that significantly. So that's neutron radiation.
All right, thank you.
You're welcome.
All right, so
Okay. Go ahead, Richard. Yep.
so questions. I see your CAGR, your 4 billion, and your curve climb. What I hear as part of this is that you have a hydrogen infused biomaterial that you need to apply to things like electronics. Let's set aside the humans because I'm pretty sure we're not going to be spraying humans with hydrogen biomaterials yet. I'm sure you're working on that though. Can you give me some insight into what the process is and how you get into production lines, how you get into refurb, how you get into like the sequencing? It's one thing to say there's a market and here's how much it costs them. It's another to say I now have a truck to go pick up their stuff. It brings it to me. Here's how I do it. I give it back to them. There's QA, QC, all these things in the the boring part of material science. A little bit of insight, perhaps, how you envision scaling and eating some of that market space, please.
Yeah, definitely. Great question. So let me start with how do we actually serve the market and how do we sell the products essentially. So if you have a mission, you would share your mission details. So orbit details, we'll do some simulations, we'll calculate how much radiation you'll be exposed to. And based on that, we will develop a solution. And then it just depends on you and the results that we get from that simulation. So if you need extra shielding, we would do the conformal coating for you plus enclosure shielding. So printing the 3D boxes where you can put in your electronics. So that for conformal coating, you would actually have to ship your electronics to us, and we could do it ourselves and ship it back. But for instance, if you don't need conformal coating or you don't prefer that, and you just need enclosure shielding, we could just ship it directly to you within 2 weeks. Maximum, it would take us 3 weeks. So those would be the lead time on enclosure shielding. And it just depends on how long it takes us to go through your mission details, run the simulations, but usually 1 month for conformal coating as well. And in terms of market and how we sort of calculated that, so like I mentioned here in my slide, let's go back. So 24,000 plus satellites in next 4 years, right? So assuming a satellite is about a ton, um, each 1 ton satellite has about 20 enclosure boxes that we're selling, and those are solid aluminum. And each costs about, on average, let's say 50,000, and it goes up to 100,000 as well. So when you do the math there and calculate it, it comes out to be about 3 to 4 billion every
Okay.
year. So
So let
that's
me
how we went through that. Yeah.
so let me ask you then just a detailed question. So if it's 24,000 over 4 years, let's call it 6,000 a year for easy math. I was a Marine, so I like simple numbers. The how do you, and let's say there's 10 boxes in each of these, how do you plan on servicing 60,000 boxes in a 12-month period to eat or to be able to receive that revenue? Is this you have warehouses planned, you have a workforce planned, you have what is it's a lot. I mean, on a scale of 1 to 10, that's a lot.
Yeah. So we're currently working with contract manufacturing organizations
Okay.
for scale up production of our material.
Got
Right
it.
now, we have few bioreactors, and with that, we're able to just service uh, 2, 3 satellites a month with the material that we have. But soon we'll be raising our pre-seed round, and then we'll be moving into an actual production facility. We'll be able to scale up our production and actually start serving bigger satellites. So, like for instance, we're in touch with DARPA and also Amazon Kuiper project, and also Millennium Space Systems. So all of that combined, we're looking at a deal of about 6,000 satellites.
Got it. Okay.
So for
I
that,
hear
we're
a lot of CapEx, a lot of or partnerships, right? Bioreactors and whatnot. Okay.
there you go.
Very interesting. Yeah. Thanks. I
Thank you.
appreciate it. Super informative.
Anybody else? We have about 3 minutes for questions.
I have just a quick question, Mohammed. Have you guys done thermal analysis? Because when you have an enclosure or a conformal coating, there's going to be a heat buildup.
Yeah, 100%. So we have to go through extensive amount of testing. So threshold testing with radiation, proton, neutrons, and also thermal, like you mentioned, and also tensile strength testing. So we're working on that. We've done a lot of that, but we still have to do more. And I'm happy to share data sheets regarding that as well.
Thank you.
Yeah, definitely, man.
So let's see, Mo or Shay? I don't know who was first.
Go ahead, Shay, because I'm just extra.
There you go.
Awesome.
Extra import.
Well, very, very clean pitch and very great job breaking down. Like I said, it's a very difficult solution. In 5 minutes, it's really hard. I mean, it's the very difficult feat to do. And I think a lot of the questions asked very great technical clarification. So I'm not going to harp on any of that. I would love to understand your personal calling, why you were gravitated to this issue. I mean, you all have relevant backgrounds on your team, but what was it about space radiation where you figured that you need to launch this company and are losing sleep over it right now?
Yeah,
Dedicating
100%.
your life to this solution.
Yeah, definitely, man. Thank you. I would say like it's just a personal passion. I want to be an astronaut. And like I mentioned, after training my whole life to become an astronaut and then, come back and then see, okay, I have high chances of getting cancer. Like this is something I wouldn't want to be worried about. And I started researching about space radiation, and that actually led me to work alongside NASA. But then when I sort of um, looked deep into the problem and saw that, okay, it's also the satellites, not just the human part that is, affected and at risk. So at that moment, yeah, I just decided to take pause, and then pause college and everything, and just go full time on this because this is something that I'm building for myself essentially, and then it also just impacts um, the space industry at large scale essentially. So those were like few motivations behind this.
It's a great story. Seriously, it's a very very unique story as well. And I mean, as you guys go out for this pre-seed rounds, make sure you talk about that because right, like the space tech and defense tech world has just gotten such a crazy influx of companies joining and random reasons, and a lot of it's people wanting to capture a slice of the pie for themselves. I mean, you have a very driven story, so I think what'll help you stand out as well outside of your very unique technology is a personal passion for it, right? I mean, that's a big thing we look at in our investment process is why is this founder going to be losing sleep, and if it's because they want to, you want to be an astronaut and you're going to help astronauts, it's a very valid reason. So yeah, great work.
Thanks so much, man. Yeah, definitely. We'll keep that in mind.
Okay, there are 20 seconds left. Mo, did you want to get something in real briefly?
I was going to ask about competition and what are other ways of being able to diminish the effects of radiation on both humans as well as the equipment?
Yeah, let's start with
10 seconds.
Probably a long.
we'll
talk
talk more
another
about
time.
yeah, we'll talk later, definitely. But I would say
Good job on
currently
your presentation.
okay, we're time up. Okay, cool.
So sorry,
I'll send you an email about that.
I hate being the bad guy on cutting these conversations short, man. Okay. And Damon, you had your hand up once again, and we never got to you. But thank you, Mohammed. It was fantastic topic, fantastic conversation. Good talk. All right. So to keep everybody on time, we're going to move right on to Argo Nav Surgical. Are you with us?
I am.
Okay.
This will be one of those odd projects. Hang on, let me see if I can. This will be a little different for you.
We love the different odd projects.
Very different. So, okay. Let me just hang on one sec. Okay. So good afternoon. My name is Mike Biga, and I am the founder of Argo Nav Surgical. With respect to the company name, it comes from two special references for me. That first is that famous ship, the Argo, that took Jason and the Argonauts out for the Golden Fleece. The Argo was built with divine assistance. It has a deep connection to exploration. For the second reference, I'll wait to the end. For a little background on me, I have past startup experience with Pathfinder Technologies, brought the first FDA-cleared image-guided liver surgery system to market. With respect to vision, Argo Nav Surgical is focused at solving the problem of providing surgical care in the most constrained resource environments for the purpose of maintaining life and mission. The Argo Nav solution I am advancing today is a robotic-enabled surgical navigation assistant, or RESNA. RESNA is a single modular platform that combines custom robotic arms with augmented reality. It is specially designed for constrained resource environments, and it represents a critical protection against catastrophic mission failure by enabling simple surgery. So the problem, when you think about extended manned spaceflight or distant space stations or the colonization of the lunar or Martian surface, you have to ask yourself, what happens to the mission if an astronaut has a broken bone or needs an appendectomy or a gallbladder removed or a kidney stone or a cavitary injury? Even with the best healthcare screening, these conditions are unpredictable and likely to happen. Going further, this will only become amplified with the growth in space commerce and tourism. So in this scenario, evac is not really possible. In fact, in the Journal of Surgical Research in 2020, the survivability of a variety of medical events were considered, and surgical treatment was considered one of the top conditions where survivability is unlikely. So how do we treat operatives for conditions primarily treated by surgery in this highly constrained resource environment? Fortunately, there's an adjacent problem terrestrially that we can pursue. Across the planet, 2 billion people lack access to simple surgery due to living in a constrained resource environment. In the US, this is the rural surgery problem. In fact, 6 to 7% of all preventable deaths are associated with paucity care. Put simply, there's a distinct need to provide advanced surgical tools to rural environments. As a simple example, in the rural US, there are approximately 200,000 gallbladder procedures per year. Only about 30% of them are happening in rural medical centers due to perceived quality of care or access. In fact, former chair of the American College of Surgeons Advisory Council for Rural Surgery, Dr. Michael Sarap, states that the practice of rural surgery is really its own specialty, given the sheer breadth of procedures that need to be accomplished. This breadth of procedures is very similar to what will be faced in extended missions within space. So how do we treat these patients in a cost-effective way and be able to translate it to rural medical centers? So our solution, the RESNA platform. The RESNA platform begins with the subject's anatomical and physiological data, pre-flight for space, or preoperative for rural medicine, which is curated to models of the subject's physiology and anatomy. From there, advanced sensing imaging data provide the current injury state or disease state. As an example, ultrasound imaging is available on the International Space Station. From there, computational and AI tools are use the sensing imaging data to adjust the physiology and anatomy models for the appropriate gravity environment. All data is then integrated and transmitted into an AR display, which is used to guide a robotic-enabled laparoscopic exoskeleton to perform surgery. Lastly, in either environment, operatives need to be able to practice. A fully haptic virtual surgery simulator is also available. So the opportunity, we estimate the market in the space to be approximately 2 million to 6 million per year over the next 3 decades with natural amplifiers as the industry matures. On the adjacent problem, we estimate total revenue on the order of 60 to 100 million over the next decade. For our next steps, we will finish our prototype in 1 year for the adjacent problem. That's the one we're working on. We are continuing to register our IP, and our desire is to partner really with another company for the space side. Possibilities include a major equity stake, licensing, or subcontracting. So we're still more in a raw phase right now. As far as the team goes, it's primarily technical, but on the team, we have developed expertise showing into the right. The leadership structure covers operations, the technology itself, the medical application, the information, and a great design team. We are looking for probably a CEO and a CFO and some help in that regards. And then in closing, I did say I would give the second company name reference at the end for those 80s nerds that are out there. The Argo was also a space voyaging ship in the anime show Star Blazers, which I watched as a kid. Are going to be very appropriate for this pitch. So I hope you will support our technology as we extend surgery for visitors among the stars and for our neighbors here on the Earth. Thank you.
All right. Thanks, Michael. Appreciate it. Damon, I do see your hand, but I've got to give the advisors a chance to get their thoughts and questions in first, and then we'll make our way back to you if there's time. Do we have any thoughts, questions, comments from our advisors? Richard.
All right, you had me at Star Blazers at the end. My is resonating deeply. So clean, fascinating layout for this. Super interested and super interested to follow up on it. The dual prong strategy, I put a heart around it. I don't know if I've ever done that in a pitch, and this is not the first pitch I've heard. That is a great risk reduction strategy for 2 very different yet highly related markets. So the way you laid that out was well done. Keep that. If you change other things, keep that sequence that you walked through was clean. Interesting. You hit the open to partners, the licensing, the number of ways in which the company can exit. I think for something like this, the ROI, and Erica, I know I can see it already in her head. This model that she's talking about in her mind. It's that would be an interesting piece to depict more from the investment side. You play to the heart mostly in this rural strategy, this market, and those things, but the very specific ROI on where these costs are, what you can displace, what you think this looks like, fielding, maintenance, and how that really rolls into this bigger item. I think that's worth some rigor on those numbers, and that would possibly reach a tipping point. But really, in the second time founder, I mean, you've obviously the game on this one, right? Just saying I'm a second time founder. Next slide is a great way to start a pitch to an investor. Yeah, that's fascinating.
Appreciate it.
Yeah, I'll double down on that. I mean, really nicely done, Michael. I think there's a lot here. I think it's a market that is fairly well understood in large cities, right? But also growing for military applications, for rural applications, as you pointed out. I think that there's been a lot of interesting federally funded programs that you could point to as evidence of the growth on the trajectory. On the space side in particular, the Canadian Space Agency has put a lot of thought into this area. They are very keen on how their expertise in space health ties to their rural health markets, particularly in far reaches of northern Canada. Worth taking a look at them as a place for collaborators or for funding. I guess the thing that sort of surprised me was how small the markets were, knowing how much a Da Vinci costs, right? And knowing that there are things that you're trying to displace. What's the advantage of the approach you're taking, and why aren't you having another 0 on the end of that?
Well, that's a good question. First of all, I think I'm being relatively conservative. I mean, I have like a little bit of slides to show a little bit on this, but
Good.
So, rural medicine is not an area where robotics is really penetrated at all. And it's because it's expensive. The recognition is that, surgeons also is the personnel problem. There's been a degree of personnel going into the rural medicine. Now, that said, if you can maintain robotic skill sets, I think that may reverse. And so I think I'm being really conservative on the rural medicine side. I cast this about a $50,000 unit. So we're trying, because this is part of a Wellcome Trust grant that we're doing, which is supposed to democratize surgery to the world kind of thing. And basically, we're kind of coming in where our product costs. We're trying to keep it around $5,000 to $6,000, $7,000, and so really a 10x markup is $50K. And so when you think about the nature of we have about 60 just in the U.S. alone, it's about 66,000 gallbladder procedures that are done currently. That can be expanded to 200,000. And if you think about the other procedures like hernias, appendectomies, all those specialties kind of reside in here as well. So actually, I think I'm being conservative in that. I'm thinking the numbers kind of look like this. Roughly there's 540 hospitals that are doing all of these procedures right now. I think that 95% of all laparoscopic procedures are done. Gallbladder procedures are done laparoscopically. So I actually think this market is completely catchable to some degree, if you're first in kind of thing. And then I think if you think about 4 units per center, which is roughly 5 surgeons per every 100,000 folks in a given area, it really comes out conservatively about 62 million and 100 million if you're thinking about capturing the whole market. And I think actually it's much larger than that.
You might throw the growth curve for Da Vinci in your backup charts, as showing other paths that more expensive technologies have taken.
Da Vinci's not translatable to medical centers, which is a problem, right? Yeah. So I think, and then the space mission part was I found that the most struggle. I struggle with that. I've never done that kind of projection, and I did it based on the number of missions, and how many units I thought would be sold, and it doesn't take into account any commerce or any kind of tourism. Or really, the colonization, and I think there's probably more of an amplification in there, but that's not my super expertise. I tried to glean as much as I could from the literature, and I came up conservatively with that kind of amount of money. But maybe you have better thoughts on that. Damon's got a hand up.
Go ahead, Damon.
Oh, they're going.
Hey, yeah. So a couple of quick things. Number one, I did catch the reference, and Argo was the English version of the ship's name. It was originally Battleship Yamato. So it's a tribute to the World War II battleship from Japan. So anyhow, getting my space nerd on for a second. I think your assessment of the rural health market actually I think is low. The burgeoning paleo telecommunications and broadband market is actually going to make it more affordable so that you can have outreach to rural areas and basically have reach back to the experts, and through telemedicine, actually have a little bit more of a robotic presence with expert on the distant end and maybe a less trained person on the front end than you may have given it credit for. So when I see your presentation, I think your flow is maybe a little bit underestimating what your rural medicine is, and maybe a little bit overestimating what your space opportunity is, at least in the near term over the next 5 to 10 years. Over.
Yeah, I get what you're saying. I think I totally agree with that. I think I think I'm being very conservative on that part of it as well. And I think there's a telemedicine aspect to this, but in some sense, telemedicine doesn't make as much sense with the space problem because you can't transmit that far distance. So there's a conflagration there, but I think it's something where the rural medicine would be it is underestimated. I'm pretty certain of that. Yeah.
Hey, any Susan?
Hi. Yeah, so can you share your team slide for me?
Yes.
It's very, very quick. So we've been in this field, in this area of space medicine and providing surgical disaster relief here on Earth as well as in space, and developing technology. So and that's been over a decade. So I'm looking at your team. I don't see any MDs or so. How are you
Cameron's
working
actually,
in this? Sorry, go ahead.
yeah, Cameron is actually the director of Division of Surgical Oncology here. So he's actually a chair of surgical oncology.
Okay, so are you working with medical doctors in technology that's very involved in technology? Are they part of your advising team or going to be onboarded into your team? Because obviously you're in surgical, that surgical realm, and you're trying to converge the surgery, medicine side, and also technology, right? Robotics and so on. So I'm just interested.
That's correct. Yeah, I'm the director. I'm also the director of Vanderbilt Institute for Surgery and Engineering. So we have like about a ton of physicians that are involved. Cameron is he's actually our prototype person who works on the system. In fact, if you catch this video right here, that's actually Cameron testing it out. So we have a couple other surgeons that are also involved with that as well. And so we have a pretty good cadre of folks. And then we have there's lots of other robotic projects that are kind of conventional robotics fields. But yes, we do. We also have so this grant right now, I said we're going to finish this prototype within year one. So basically we have the Wellcome Trust and part of the SAVE project. If you look at they have a whole program on that. We're one of those competitors. And so we're trying to finish this within a year. We're going to have some folks from across the seas as well, trying to work with us as well as over at Stanford. So we have quite a few test folks that are going to work on this. Yeah.
Great. Yeah, well, interested in, I just put all my information directly to you. So let's chat and see. We got a $3 million grant with the DoD developing medical XR for disaster relief in space. So there's a lot of synergy here, but this is an area I think there's a lot of innovation, but also a lot of funding. So I really, kudos to you too. But it's a challenging area, I'm going to tell you.
It is absolutely challenging. I mean, the goal of the original project is to do medical training in areas that don't have medical. I mean, you see when do and teach when only works when you have a medical academy to do it. And so the idea of the simulator part of this, that's what we're working on, to kind of facilitate. Can I train somebody to do a gallbladder procedure without them necessarily having a full-on medical school there? That's kind of you're absolutely tough problem.
Yes, but it's needed if we are going to, actually live in space. But anyway, that's great. You can reach out to me and we can chat more. Thanks so much though for presentation.
Thank you.
We are well over time and they are about to kick us out in 50 seconds. So Richard, I know you've got something to say.
Mike,
you can say it before we're all booted out.
Mo's thinking it. Data. Would love to talk to you about your data play on this. It's fascinating. And your space strategy, I would pitch as a risk reduction strategy for go, no go for launch, not for units marketed and ROI'd. Very different calculus in all of that. If you've only got one, it's like selling a cheeseburger. I just need to sell it for $50 million, right? So that's a very interesting approach there. Happy to talk more.
I'm a thrifty guy.
Thank you, everyone. Thanks. Tara, thank you.
Thank you, Richard. Thank you, everyone. Thank you, Michael. They are booting us back into the main room for a quick wrap up, or else you can kick yourself back over there now. So I'll see you on the other side.
Thank you, guys.